Let's look at an inequality. So we're going to look at this a little bit differently because it makes it a little easier to understand than if I were to explain it the technical way. So we have an absolute value that's less than 5. So we know from previous lessons that if we have a negative absolute value, so let's just look at this. Let's just go back and re-examine this. If I have the absolute value of negative 5, that equals 5. And if I have the absolute value of 5, that also equals 5. So we're going to take this concept of the absolute value can be negative on the inside or positive on the inside to help us deal with inequalities. So we're going to set this up in two cases. We have case 1, and that's going to be where we're going to take it as is. We're going to call this whatever's inside, that's going to be our positive. So we're going to have 2x minus 1 is less than 5. And then we're going to have case 2. So this whole value could be negative. So it's going to be negative 1 times 2x minus 1 is less than 5. Okay? All we did was we took the positive as is value, and then we took the opposite value. If you multiply it by negative 1, that gives us the opposite value. So let's go ahead. Everything else is the same. I want to point that out. Less than 5, less than 5. So if we go ahead and solve for x, we're going to add 1 to both sides. So that gives us 2x is less than 6. Divide both sides by 2. So that gives us x is less than 3. Okay? So on this side, I'm just going to go ahead and distribute that negative in. So I get negative 2x plus 1 is less than 5. Subtract 1 on both sides. I get negative 2x is less than 4. Divide both sides by negative 2. Be careful here. When you divide an inequality by negative, that inequality has to change direction. So this becomes x is greater than negative 2. Okay? Because I'm dividing by a negative, my inequality has to flip. So, let's see. I'm going to draw this on a number line now. And I'm going to have to figure out what's the best way to graph it. So, here's my number line. And I'm going to put negative 2 here. And I'm going to put 3 here. So let's look what this is saying. This is saying x is larger or greater than negative 2. Well, where's that? That's this way. Every value here is larger than negative 2. But it doesn't include negative 2, does it? Because I don't have an equal sign there. If it was that little equal bar underneath, I would color that in. Here, x is less than 3. X is less than 3, so that goes that way. Now remember, lines can go forever, correct? So I'm wondering, does that mean this line goes forever this way and this line goes forever this way? What does that mean? Or have I in fact graphed it? So what we're going to do is we're going to check our answer. We're going to pick a number that's within this interval to see if it's true. If it's true, then we know our answer is true. But we're going to double check, and we'll check something that should not be true on the outside as well. So let's see if this is true. I can pick any number between negative 2 and 3 and put it in my original equation, and it should work. What would be a good number to pick? How about 0? I like the number 0. It's easy to work with. So 0 is between negative 2 and 3. We're going to put that into our regular our equation that we had, and we're going to see if that works. So here we go. So we're going to test this out. So the absolute value of 2 times 0 minus 1 should be less than 5. So that's 0 minus 1. The absolute value of negative 1 is less than 5. Well, that's true. So good. So that must be our answer. But let's just say we're not quite sure. So let's pick a number outside our answer interval. Let's just pick the next integer up, which happens to be 4. So I'm going to test 4. And to make sure, 4 should not work according to this graph. It should end right before we get to 3. So if I have 2 times 4 minus 1, that should be less than 5. I work that out. 2 times 4 is 8 minus 1, less than 5. That means the absolute value of 7 is less than 5. Well, that's not true. The absolute value of 7 is not less than 5. So we know this is not a solution. So that means that this here is correct. I graphed it correctly. Okay. Now another way that you can remember this without having to go through all that trouble is let's look at our absolute value sign. Okay, so in our absolute value sign, notice this is the absolute value, and how do we say this? Less than. Okay, so the absolute value is than. Notice I use the word and. This is an and. This means, and means what they share. Okay, what they share. So if we look at our original problem of what they share, well, remember I said less than 3, so that technically keeps going that way, correct? And greater than negative 2, that goes that way forever, correct? What they share is in the middle. So this was an and problem. Our graph graphs only what they share.